Hello guys, welcome back to another video on the topic of complex number. So in last video, complex number, complex number. So in last video, what we have understand that complex number is a mixture of real number and imaginary number. Okay, so when we mix real number and imaginary number, then we get the real number. For example, if I write 2 plus 3i, then this is a complex number. Okay, and we can represent it with a z equal to 2 plus 3i. So this is a complex number. Now you see there is two part. Okay, first one 2 and second this 3 1. So this 2 is called the real real part, and this 3i is called the imaginary imaginary part. Okay, so and this 2 and this 3 both are a real number. Okay, so now let's see the algebra of a complex number. Okay, and before we start, I let me tell you that if we have two complex numbers, suppose z1, that is 2 plus 3i, and the second one z2, that is 5 plus 3i, and if z1 is equal to z2, then its real number will be equal and its imaginary number will be equal. Okay, so 2 will be equal to 5 and 3i will be equal to, sorry, 3i is equal to 3i. Okay, uh, on this concept, let's solve a equation. So we have a equation, and here we have to find out what is the value of x and y. Okay, so let me just find it. So before we move, let me just clear that we are taking all the examples of from the NCERT class 11th. So all the example and exercise will be going to from the NCERT only. Okay, so you see we have 4x plus I, we have 4x plus I, 3x minus y equal to 3 plus I minus 6. So this is a example 1 of NCERT, and here we have to find out what is the x and what is y. Okay, so we know that if two complex numbers are equal, then its real part will be equal and its imaginary part will be equal. Okay, so we can write 4x, let me just clear because it's not looking good. Okay, so 4x, this 4x, that is a real part, will be equal to 3. Okay, so x equal to 3 by 4, answer, first answer. And second, this imaginary part 3x minus y will be equal to minus 6. So 3x minus y equal to minus 6. If we put the value of x, that is 3 by 4, 3 by 4 minus y equal to minus 6. So we can write it like 9 by 4 minus y equal to minus 6, or minus y equal to minus 6 minus 9 by 4. Write it minus y equal to 4 minus 24 minus 9, yeah, minus y equal to 33 minus 33 by 4, minus minus cancel, so y equal to 33 by 4. So this is the answer. Okay, now let's move and see what is the algebra, a different algebra of a complex number. Okay, so first we have addition. Okay, we can add two complex number. So what we can do here, just take two complex numbers. So if we have a complex number z1 and z2, suppose this is a plus ib and this is a plus, sorry, not a, it will be confused, c plus id. Suppose we have these two complex number and we want to add this, addition of complex number. Okay, so what we can do, we can add this real part, a plus c plus I b plus d. Okay, and this will be the answer. So let's take one example here and let's find out. Suppose we have z1 equal to 2 plus I3. This is also again from the NCERT, and z2 equal to minus 6 plus I5, and we have to add this. So what we can do, a2 plus minus 6, 2 plus minus 6 plus I b and d. So uh, what is b? 3 and 5. So 3 plus 5 equal to, this will be plus minus minus, so minus 4 plus I8. So this is the answer. Okay, next, difference of two complex number. Okay, ai double f e, difference of two complex numbers. So suppose I have z1 equal to a plus ib again, and z2 equal to c plus id. Okay, so z1 minus z2 will be z1 plus minus z2. Okay, this is very simple. Okay, we have to do the addition only, but in z2 we have to put the minus. Okay, so let's take one example here. So z1 equal to 6 plus 3i, and z2 equal to 2 minus I. Okay, so what we can do, 6 plus 3i, we will write the z1 plus minus z2. Okay, so minus 2 minus I, so it will be 6 plus 3i, 6 plus 3i. So you see, plus minus, it will be, this sign will be changed. Okay, so we don't need to make it so complicated. Just do plus minus minus, and z2, the z2 will be opposite. Okay, so plus minus minus 2, and minus minus plus I. Okay, now let me just clear this. So 6 minus 2 is 4 plus 4i. Okay, so this is the answer. Now the third one, multiplication of complex numbers. Okay, just don't focus on my handwriting. Now multiplication of a complex number. So if we have z1 is used to represent the complex number. Okay, so z1 equal to a plus ib. Okay, and the second z2 equal to c plus id. Okay, so what will be the z1 into z2? Z1 into z2 into z2 equal to, it will be, we will do something. Okay, then we will plus iota, and then again we will do something. Okay, so here what we will write, a into c, like this, a into c plus b into d. Okay, b into d. Now we will do the cross. Okay, so a into d, ad, and here I think, here we will do the minus. Actually it will be negative, and A into D plus B into C, BC. Okay. Now let's take one example where we will just check it practically. So I have Z1 equal to, again this example is from the NCERT, Z1 equal to 3 plus I5 and Z2 equal to 2 plus I6, 2 plus I6. Okay, so what we will do, we will do something, then add iota with something else. Okay, so here we will do first 3 into 2, that is 6, minus 5 into 6, that is 30. Okay, now again we will do a cross, we will do the cross, so a d, that is 18 and plus 5 and 2. Okay, so it will be 10, so it will be minus 24 plus iota 28, and this is the answer. Okay, now let's move to on the next question, and that is the fourth one. So now we have completed addition, difference, multiplication. Now we will see division. Okay, so in division, suppose we have division, division of complex numbers. So now let's see the division. Okay, so the fourth one, division of complex number. Okay, so division of complex number. So what happened here, if we have, let me just zoom it. So if we have z1, if we have z1 and we have z2, and we want to find out what is the z1 by z2, so there is a condition that z2 cannot be 0. Okay, so z1 cannot be 0. So suppose if I have, okay, and z1 cannot be 0, the first thing, this is the first thing. Second, z1 by z2, z1 by z2 can be also written like z1 into 1 by z2, right? And this is the second thing that we have to keep in mind. Now third thing, that 1 by z2 is equal to a by a square plus b square plus I minus b by a square plus b square. Okay, so these three things will help us to find out and to solve the problem statement. Okay, so now suppose I have z1 equal to 6 plus 3i and z2 equal to 2 minus I. Okay, so let's break it down. So this is not a 0, this is not a 0, so we can proceed further to I. So z1 by z2, so we can write it like z1 into 1 by z2. Okay, so z1, I will write z1 6 plus 3i, right? And into 1 by z2 is 2 minus I, 2 minus I, right? Now I can write this 1 by z2 in this form, right? So let's write it down, 6 plus 3i into this is a and this is b. So a is 2, b is minus 1. Actually this is iota, so 1 is hidden there. Okay, so we can write it like this is a, so a by, actually there should be some proper space here, let me just clear this also. Okay, so I can write 6 plus, no, so 6 plus 3i, okay, into a by a square means a is 2, a that is 2, 2 square, sorry, 2 by 2 square that is 4 plus minus 1 square equal to 1. Okay, and we have completed this. Now plus I minus b by, so minus b, so what is b here? Minus 1, minus 1, and we have to keep this in negative, right? Plus 4 plus 1. Okay, now we can write this as a 6 plus 3i as it is, into 2 by 5, 2 by 5 plus iota minus minus plus 1 by 5. Okay, or we can write this as a 6 plus 3i into 5, 2 plus I. Okay, so now we have to multiply this. This is, now we have found the answer. If we multiply this, simply we will get the answer. So we will multiply all these with 6. Okay, so it will be 6 into 2 plus I by 5. Okay, plus 3i into 2 plus I by 5. Okay, so it will be uh, 12 plus 6i by 5 plus 6i plus I square by 5. Okay, now we will take the common 5, so 12 plus 6i plus 6i plus I square, that is equal to minus 1, so it will be minus 1. Okay, now we have yeah, so it's minus 1, so 11 plus 12 I by 5. Okay, so this is our answer that we have concluded, and I think everything's fine. Hope, yeah, 6i and 3i square should be there, no? Okay, so there is a mistake. Yes, I was thinking there is a mistake. So here we have done some mistake, and the mistake is when we multiply I with 3i, then it will be 3i square actually, right? And when we take common 5, it will be 12 plus 6i plus 6i plus 3i square. Okay, so it will be 12 plus 12i minus 3 by 5, and it will be 9 plus 12i by 5. Okay, so this is the answer, and this is the multiplication, division of complex number. Now next we have the power of I. Power of I. So in last video I have already explained this to you, that I equal to under root minus 1, I square equal to minus 1, I to power 3 equal to I to power 2 I, that is minus 1 into I, that is minus I. Okay, I to power 4 equal to I to power 2 into I to power 2, that is minus 1 into minus 1, that is 1. Okay, so we have already completed this. Now next we have the square root of a negative real numbers. So suppose if I have I, okay, if I find what is the value of I square and what is the value of negative I square, so it will be I is, so I square will be minus 1, and minus, when we will do the square, then minus minus will be cancelled and it will be also minus 1. Okay, suppose we have under root minus 5, under root minus 5 into under root minus 10, suppose. So what will be the answer here? Okay, so we can write it like minus 1 into under root 5 and okay, let's just skip this, we are going off track. Okay, so this is the basically what happens, right? So now in next video we will start doing the examples, and for this video we have done, there is one last thing, that is identities. Identities, TITES, identities. So identities are same like a plus b a whole square and a plus b का whole cube, a plus b plus c का whole cube. So it's very similar like this. Okay, so if you want, I can just tell you that if we have, suppose we have z1 and z2. Okay, so we have to find what is the z1 plus z2 whole square. Okay, what will be the whole square of z1 minus z2? So it will be z1 plus 2 2 into z1 into z2 plus z2 square. Okay, so same like that, z1 plus z2 ka whole cube. Okay, and again z1 plus whole cube, then square cube, and then we have to do the for the negative also, z1 minus z2 whole square, z1 minus z2 whole cube. Okay, now we have z1 square z1 square minus z2 square. So this is all same like a plus b ka whole square, a plus b ka whole cube. Okay, so in next video we will start practicing the examples, and we will make a one last video and we will complete this. Okay, so I hope this is helpful for you. Thank you so much for watching this video. Bye bye.